Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem number 31. Okay, that is fluid mechanics, problem number 31. As usual, we first come towards statement of the problem. A hollow cylindrical copper pipe is 1.50 meter long and has an outside diameter of 3.50 centimeter. Dear students, we are not primarily concerned with centimeter, we are concerned with meter. So definitely we will have to convert the centimeter into meter, okay? And an inside diameter of 2.50 centimeter, okay? Here again we will convert the centimeter into meter, okay? How much does it weigh? Dear students, problem is quite simple. Actually we have to find two volumes, okay, inner and outer, and then we have to calculate net, and then our problem will be almost solved, okay? Solution. Dear students, this part of this solution has been previously shown several times, okay? We know that formula for calculating volume differs according to different geometrical shapes. So here we have shown this formula for calculating volume for four different geometrical shapes, okay? Rectangular solid, length into width into height, sphere 4 by 3 pi r cube, cylinder pi r square h, and cone 1 by 3 pi r square, okay? Here we will use this value, okay? We now start our solution in a formal manner as we have done with previous problems of similar nature, okay? Density is mass per unit volume. If a mass m of homogeneous material has volume V, then its density rho is given by rho is equal to m over V, mass over volume, okay? Equation number 1. We know from table of densities that density of copper is 8900 kilogram per meter cube. Dear students, here we will show table of densities. First we show that a hollow cylindrical copper wire, okay? Copper is under consideration, okay? So now we move to table of densities in which we will see copper's density, okay? Where copper? This copper, okay? Right column, third row, okay? Copper 8.9 into 10 raised to the power 3 kilogram per meter cube, and it can be written in alternate form as 8900 kilogram per meter cube, okay? So to this extent no confusion, okay? We know from table of densities that density of copper is 8900 kilogram per meter cube. Now dear students, because there is an inner radius and outer radius, so first we designate some letters for this purpose, okay? Let R1 be the inner radius of the hollow cylinder, let R2 be the outer radius of the hollow cylinder, okay? Then this implies that R1 is equal to 2.5 centimeter divided by 2, okay? Because this 2.5 is not radius, this is diameter. We again move to problem. Diameter, okay? These two values are diameter, and we have to calculate radius by dividing that value by 2. Moreover, centimeter will be converted into meter. So in short, R1 becomes equal to 0.0125 meter and R2 becomes equal to 0.0175 meter. Okay, so to this extent I think there should be no confusion. Okay, everything is clear. Let us now calculate volume as under. Okay, dear students, as there is a inner radius and outer radius, then definitely volumes will again be of two nature, inner volume and outer volume, and then we will calculate net volume, that is outer volume minus inner volume. Okay, dear students, pi r square L, inner volume is equal to pi r1 square L. We have designated R1 for inner radius and R2 for outer radius. Moreover, in the formula which we have shown in the earlier part of this problem solution, we have a slight change in the nature of this formula. What change? We remove that confusion. Okay, this pi r square L, pi r square H. Volume of a cylinder is equal to pi r square H. H stands for height, and this is a copper pipe, cylindrical pipe. Okay, a hollow cylindrical copper pipe, and we know that pipe is lengthy. Pipe has length instead of height. Okay, so according to the nature of problem, we can slightly modify our formula accordingly. Okay, so here what change we have made? Volume of a cylinder is equal to pi r square H. Here in our solution we have replaced H with L, because height and length are equivalent terms. Okay, it does not make any material difference on the philosophy of the formula. Okay, here pi r square H has been shown as formula for calculating volume of a cylinder, but in reality here we have replaced H with L, length of the pipe. Okay, moreover, inner radius is R1 and outer radius is R2. So volume, that is pi r square H, will take the form as pi r1 square L, and in case of outer volume it will take the form as pi r2 square L. Okay, next what we have done, we have simply put the value of pi, which is 3.14. Okay, how the 3.14 comes? 3.14 comes when we divide 22 by 7. Okay, 22 divided by 7 gives a number whose decimal representation is non-repeating, non-terminating. It goes endlessly after decimal. Okay, this is a very special number, pi, 22 by 7. But usually we restrict our decimal representation only to 2 decimal places. Okay, what we have done, we have put the value of pi 3.14. We have placed the value of R1, that is R1 square, which we have shown in the first step of this solution of this problem. Okay, similarly we have used the value of R2, which we have shown in these starting part of this problem. Okay. Moreover, we have used L equal to 1.5 meter, which is given in the problem statement. 1.5. Okay. How 1.5? 1.5 meter long. Okay. A hollow cylindrical copper pipe is 1.50 meter long. Okay. So this is L. 1.5 meter. Okay. While formula which we have shown includes H, and H and L are equivalent terms, so according to the nature of problem we can slightly modify our formula. Okay. So inner volume has become equal to 0.0000736 meter cube, and outer volume has become equal to 0.00144 meter cube, and hence this implies that net volume will be equal to outer volume minus inner volume equal to this minus this, and hence this becomes equal to 0.000704 meter cube. Okay. So dear students, we have found volume or net volume, which becomes as 0.00704 meter cube. We can, as a matter of discretion, convert this quantity in some other mode. Okay. What other mode? If we write it as 0.704, then we will have to multiply it with 10 raised to the power 3. If we convert it with 7.04, then we will have to multiply it with 10 raised to the power 4. But there is no need for such extra steps. Our answer is quite satisfactory to this extent. Now, using equation number 1. Okay, what equation number 1? This is equation number 1, that rho is equal to density, rho is equal to mass over volume. Okay. Density, this density is given in the table of densities, where density of copper is given as 8.9 into 10 raised to the power 3 kilogram per meter cube, and that was written in this form as 8900 kilogram per meter cube, and M is unknown, so we have not put value of M. M is still as it exists in the as it exists in the equation. Okay. Moreover, in place of volume we have calculated this. So okay, so in place of volume we have used this value 0.0004704 meter cube. Okay. This implies that mass which we have to find out will be kept on one side, and this thing will be shifted on other side of equality, and this denominator will be multiplied with 8900. Okay, 8900. Okay. So dear students, here meter cube will be cancelled out with meter cube. Okay. In order to justify this step, we can argue that we multiply both sides with m cube. Okay. So both sides m cube will be cancelled out. Okay. Okay. And simply mass m will become equal to this value, 6.2656 kilogram. Okay. So our mass has been found successfully, and it is quite satisfactory solution. We can round it to only 2 decimal places, 6.26, but even up to 4 decimal places it is quite okay. Okay. We have found mass m. Next we will found W equal to mg. Okay, according to Newton's second law of motion, which gives us formula F equal to ma. So that formula has been here applied in a slightly different manner. Okay, so weight W will become equal to this mass into acceleration due to gravity 9.8 meter per second square. Okay, this constant we are dealing with this from very earlier classes. Okay, so this implies that weight W has become equal to 61.403 Newton. Okay, because dear students, here kilogram meter per second square is the definition of Newton. Okay, 6.2656 when multiplied with 9.8 will become 61.403, and we know that definition of Newton is such that it involves these three units: kilogram into meter divided by second square. So here it has been become Newton. Okay, in the next step we have converted Newton into pound. Okay, so this weight W, which was equal to 61.403 Newton, to this extent our problem is 100% complete. We do not need to go further, but as a matter of discretion, because sometimes we have to follow or adopt various fashion styles. Okay, unnecessary conversion factors. So we have converted this Newton into pound, which has become equal to 13.803 pound. We can round this value as about 14 pound. However, we need not to round it into 14. Exact value 13.803 pound is 100% correct answer. Now, dear students, we move to a conversion factor which will explain how we have converted Newton into pound. Okay, well, this is okay. This small table, force, Newton, pound. 1 Newton is equal to 0.2248 pound. Okay, so when 1 Newton is equal to so many pound, then so many Newton will be equal to this into that so many value. Okay, that is why this quantity was multiplied with this factor to convert it into pound, and this problem has been solved successfully. Here, this table we have already discussed this table in detail. From this table we have to take only the value of density of copper. Okay, so there is no further need of this table. We have to take the value of density of copper, which we have already taken, and from here this table was just to convert Newton into pound. Now we move to reference. Okay, dear students, reference book is Sears and Zeman Skies University Physics with Modern Physics. Its authors are Douglas. Its authors are Hug D. Young, Roger A. Friedman, A. Lewis Ford. Its publisher is Pearson. Its 14th edition having been published in 2016, or 15th edition having been published in 2020 has been adopted or followed. And here chapter number 12 under title Fluid Mechanics is our concerned chapter, and this problem has been enumerated at serial number 7 of the exercise given at the end of this chapter, that is to say exercise number 12.7, and this is the end of our problem. Okay.